Now let's see how would we obtain a function from a given relation. For example, this is a linear equation. Okay, so we can do this. We can solve this equation for y. So solving this equation for y means we are going to isolate y. So I put everything on the other side. Now I'm going to divide by 2. So here I have y equals negative 2x plus 5 over 2. Okay, now we can graph this equation. Okay, so now I'm going to enter the expression. So it's negative 2x plus 5 over 2. Okay, and here we go, and here is a graph. All right, so here's a graph of this value of this linear function, okay, or y written as an expression in x. And let's just make a couple of quick comments about it. So I already have a graph here, but I'm going to take a different graph just to discuss the properties of graph of a function in slight detail. So here we have a graph of this linear relation from which we propose to form a function. And this indeed is a function because first of all, notice this, that for every value or for any input that we take from the domain here, it assigns a unique value to that input or gives a unique output. Okay, and I shall explain that term unique a little more. Okay, and so remember this, that is a function has to assign, okay, so a function assigns a unique output, okay, to each input. Okay, and that is the reason we need graph of a relation to pass the vertical line test in order to be able to become a function. What we meant by vertical line test is that if we make a vertical line that intersects the graph of the relation, then it should not cross the graph at more than one point. So let's take, let me just take a different color just to see another relation and show you what happens in case it crosses the crosses the graph at more than one point. So say we had a relation that was like this, okay, and we take a vertical line, and here what happens? If we make this vertical line through here, you can see that for this given value of input, we are getting 3 different outputs, and a function is not supposed to do that. All right, so this graph here, the one that I made, it does not pass the vertical line test, so therefore this cannot be a function. Let me just show you an example of a graph like this. So now let's say we are given this relation y square minus x equals 3. So what happens here? Y, when we solve for y, we will get x plus 3. So I would have what? I would have two values of y in the solution. One is the principal square root, and the other one is the negative. So you can see right here that other than the input of negative 3, for everything, like if you take x equals 6, it would give 3 and negative 3, both of them as outputs. Let's look at a graph again here. Okay, so here I'll take, say, square root of x plus 3, okay, and then negative square root of x plus 3. So these together will graph this relation for us, And you can see right here that this fails the vertical line test, that the vertical line, if when we, there are many vertical lines that when we pass through the graph of this curve, they are intersecting the graph at more than one point. So therefore, this relation will not give us a function.